In this video, I will be going over how to solve exponential word problems. So most of these word problems have to do with exponential growth or exponential decay. So that is when something is increasing exponentially over time or decreasing exponentially over time. Let's get into it. So here's an example of what the graphs look like when we're talking about exponential growth or exponential decay. So these are based off of the equation y equals a times b to the power of x. So that's just your basic exponential equation. So when the b value here is greater than 1, that's when the graph will increase. That's what we call exponential growth because it's growing or increasing. And then when the b value is less than 1, so if it's a decimal or a fraction that's less than 1, then that is what we call exponential decay, and that graph will be decreasing or going down. Here's a little tip on which equation to use depending on the word problem. So in the word problem, when the rate is given as a percentage, then you want to use this equation here. These are both really the same equation, just one of them, the one on the left, gets a little bit more specific than the one on the right. But if you break it down, they really are the same equation. So when the rate is a percent, you're going to use the equation a equals p times 1 plus or minus r to the power of t. If that looks intimidating to you, don't worry, I will break it down for you in just a minute. And then if the rate says something like it doubles or it triples, or even sometimes you'll see half-life. So if something is cutting in half every hour or something like that, if it's doubling, tripling, multiplying by 4 or 5, or if it's like a whole number and not a percentage, then it's easier to think of it like this equation, y equals a times b to the power of x. And I'll go over a few examples of these with you, and we'll work them out, and I'll show you how to plug everything into the equation. Comparing exponential growth and exponential decay. So when it is growing, that is when you're going to use the plus sign in the middle here, because it's increasing, it's growing, so you're adding. When it's exponential decay, that's when you are going to use a minus sign here because it is decreasing. And just to paint this picture for you guys so you can understand that a little bit better, this is how I always explained this to my students. Imagine that you're in a grocery store and you see a bag of Lay's potato chips. So there's a bag of Lay's potato chips, and then you see another bag of Lay's potato chips, and it says something like, now with 50% more. Right? You see things like this all the time in the grocery store. So what that means when it says 50% more is if we think of the original size bag as 100%, that means that the new bag it's this same size, the 100%, plus 50%, which would be half of this bag. So it's 100% plus 50%, and that gives you the new bag. So it's like 1.5 times the size, right? So if you think about that, and then we go back to our equation, so this 1 in the equation, that represents the 100%. So say like in our potato chip example, it's increasing by 50%, so that means the rate here would be 50%. So we take the 100% and we add the 50% to it. So that's why we have 1 in this equation, both of these equations. The 1 represents 100%. So if it's like decreasing down to 75% or something, then you would subtract from the 100%. So that's where the 1 comes from in those equations. You can think of it like it represents 100%. And then in this other example, when we have the a times b, again, that's when the problem says it's doubling or it's tripling or multiplying by 5 or dividing in half, things like that where you're not given a percent, then you want to use the A times B. Here is the breakdown of that equation for you. So the A represents the accrued amount. That means the ending amount. So you're going to start with so much of something, and then after the time passes, then you're going to end up with so much. So the A represents the amount you're left over with after the time has passed. The P stands for principal. That's the starting amount. So let's say you're starting with money. A lot of these examples deal with money. So you're investing money. So let's say you invest $50,000. So that would be the starting amount or the principal. And then you have it in the stock market. And so it's accruing, it's increasing, you're gaining more money over time. And then after so much time has passed, then you end up with, let's say, $150,000. So then the $150,000 would be the A, the ending amount. So it's just how much you're left with after the time has passed. That's the A, and then the amount that you start with is the P. The R represents rate, and again, in this equation, your rate will usually be given as a percentage. The thing that's tricky about that is, let's say the rate is 50%. So when you're actually writing out the equation and you have 1 plus, now in this spot, you're not going to write 50. A lot of students make that mistake. If the rate is 50%, you're not going to write the number 50. You're going to write the decimal 0.5. Because 50 and 50% are two very different things. So just remember to change that percent to a decimal when you're plugging it in the equation. So another example, if it's 75%, again, you're not going to write 75 here in the equation. You're going to write 0.75. So just remember to change those percentages to decimals when you're actually doing the math and plugging the numbers in the equation. And then the T in the equation represents time. So it just depends on the word problem. It depends on what it's talking about, because it could say it increases 50% every day, and then your time would be in days. Or it increases 75% every hour, and then your time would be in hours. So the time, it's not always the same units. It could be days, hours, weeks, months, years, minutes, seconds, any type of measurement of time. And that's what you'll put in that T spot. Here are a few examples of how you would use this equation. If the rate is not a percentage, but it says it doubles or triples or cuts in half or whatever, then this is how you would use that. You would put that number in the B value. So if it doubles, then your B value would be 2. If it triples, then your B value is 3. If it says it cuts in half or it has a half-life, then your B value would be 1/2. So whatever the rate is, if it's not a percentage, then you'll just plug that number in for the B value. Let's look at an example of an actual word problem. So, a house that costs $300,000 will appreciate in value by 4% each year. Write a function that models the cost of the house over time. Find the value of the house at the end of 5 years. So we need to think about every piece of this equation. Think about what's given to you and what we are supposed to find. So the house costs $300,000. So that would be the P, or the principal, the starting amount, because that's the very beginning. It costs $300,000. And then appreciate means that it's increasing. So as you know, houses will increase in value, or they will appreciate over time. So that means we're going to use the plus sign because it's increasing. And then our rate is 4%. So again, when you're actually plugging it into the equation, you're not going to put 4, you're going to put the decimal 0.04. That's how you write 4% as a decimal. And then it says, write a function that models the cost of the house over time. Find the value of the house at the end of 5 years. So that's going to be our t will be 5. And what we're trying to find is it says find the value at the end of 5 years. So we are trying to find the ending amount, which would be a. Okay, so plugging everything into the equation. We know we don't have a. That's what we're trying to find. But we do have P, which would be 300,000 times 1 plus, we're using plus because it's appreciating, so it's increasing. 4%, which would be 0.04. And we're looking for the value after 5 years. So T is going to be 5. So then, after you have all of those numbers, you can just plug all of that into the calculator, and then you will get your answer. So the answer should be 364,990, and then if we round to the nearest dollar, it'll be $996, and that is how much the house will cost after 5 years. Let's look at this next example. Bob's new Corvette cost him $80,000. Right after he buys it, it will depreciate by 18% each year for the first 4 years. Write a function that models the car's depreciation. What will the car's value be at the end of 4 years? Okay, so let's go through and figure out what we're given and what we need to find. So the $80,000, that is our starting amount or our principal. So that's the P value. That's how much the Corvette costs in the beginning before the time has passed. And then it says it will depreciate, which means it will decrease in value. So we're going to be subtracting from that 100%. And then our percent is 18%. So we would write that like 0.18, like a decimal. And then we're trying to find how much it will be worth at the end of 4 years. So that will be our time, will be 4. And again, it's asking for the ending amount. So it's asking for A. So writing our equation, we don't know A, that's what we're trying to find. A equals, the principal was $80,000 times 1 minus the rate was 0.18. And then the time was 4 years. So our exponent will be 4. And then again, you can just plug all of that into the calculator. And your answer should come out to be about $36,170. Here are a couple more examples. The first one says the population of Ogden, Utah was 84,000 people in the year 2013. It is growing at a rate of 5%. What will the population be by the year 2020? You can tell I made this problem a while ago. Okay, so the 84,000 people, that would be our starting amount. So that is the P value. And that was in the year 2013. It is growing at a rate of 5%. So we would write that like 0.05. And it says, what will the population be by the year 2020? That's the ending amount, A. We don't know what that is. That's what it's asking us for. And this one's a little tricky because it doesn't give us the exact amount of time, but it does tell us that we are starting in 2013 and we're ending in 2020. So we just have to use our brains a little bit and know that that means it's 7 years. From 2013 to 2020 is 7 years. So putting it all into the equation, we have A equals P was 84,000 times 1, and it is growing. So we are adding the rate, 1 plus 0.05 for 5%. And then our time will be 7 because 2013 to 2020 is 7 years. So then we plug all of that into the calculator and we should get 118,196.435503. So that's the exact answer. But when we're talking about people, we're not going to have a fraction of people. So we'll just say 118,196 people by the year 2020. Now let's look at this second example. A culture of bacteria starts at 250,000 cells. A poison is added to the growth medium and the cells start to die at a rate of 70% each hour. How many cells will there be after 5 hours? So we start with 250,000 cells, so that's going to be the starting amount, the p-value. And then the rate is 70%, so we're going to write that like 0.7. And it says they start to die, so that means they are decreasing, so we're going to subtract in this equation. It's asking how many cells will there be after 5 hours. So 5 will be our time, and it's asking us for the a value. It's asking us how many will there be after the time has passed. So putting this into the equation, we have a equals p was 250,000 times 1, we are subtracting because they are decreasing. 1 minus 0.7, and our time was 5 to the power of 5. So we plug all of that into the calculator. You should get 607.5. So we would say there will be 607.5 cells after 5 hours. Here are some steps to solving exponential word problems. So figure out if it is increasing or decreasing. That's going to tell us whether we are using plus or minus. Plug the numbers into the equation, or I'm going to add here y equals ab to the power of x. That's if it's doubling or tripling, or if the rate is not a percentage, then you use this equation. If the rate is a percentage, then you use the other equations with a equals p. Plug the equation into the calculator, and then write your answer in a complete sentence. Because in word problems, you are actually talking about things, it's not just numbers. So make sure you include your units in your answer and you write your answer in a complete sentence. I hope that was helpful. Please like and subscribe if you liked the video. Please comment below if there are any other math topics you would like me to cover. And thank you so much for watching.